Hello and welcome back. We're going to start programming a really simple tree program. It's going to contain something that is really familiar to you, which is only one class, which was the node class from the doubly linked list, and we're going to do everything else in main. So I'm going to jump directly into it and do the class which we called node. Doesn't receive anything, and we're going to do dunder init. So fine. Exactly like we did with doubly linked list, it's going to receive self and data, and we're going to have self.data equal data, self dot we don't have next, we have right in here, so self.right equal none, and self dot instead of previous we have left, so self dot left equal none. We can change those two, and instead we can use default values, which are default values that we can use for our parameters. So I can do something like right equals none, comma, left equals none. And I can come here and say self.right equals right, self.left equals left. That means if the user did something like this, so node for 5, which is the data, this is going to be the data, number 5 is going to be here, so self.data equals 5. Right and left are not sent in here, so it's going to take their default value, which is none. So this is going to be equal none and equal none. But if the user send right and left, then instead of taking the none value, it's going to take the value that we send and give it to self.right. So this is how we do a default value that can be used in a parameter in Python. Now I'm going to jump straight back to my main program, and I'm going to do root equals node. I'm going to use some random numbers in here, so let's say 50. So my root right now, or the head with double linked list, is a node that has 50. It doesn't have a right or left because it has none for both. And let's continue. So I'm going to do root dot right. I'm going to give it node of how much? Okay, so let's say 20. Then I'm going to do root dot left equals node for 3. Let's add some more levels. So root dot right, and that is going to equal, let's give it how much? Okay, let's say 101. And we have root dot right dot left, which is going to equal, let's give it 0. And finally root dot left dot right, and we are going to give it number 99. Those numbers are selected randomly, doesn't have anything to do with anything. So I'm going to use really complicated software to draw this, which is definitely not Microsoft Paint. And let's see. So I have root, which is 50. This is my root, 50. Then I have root.right, so to the right of it is number 20. Root.left is 3, so to the left is 3. I have root.right.right, so to the right in here is 101. Root.right.left is 0. And I have root.left.right, which is 99. So those are the numbers that we have entered. But as you can see in here, I have no way of printing them. Well, you can choose one of the 3 methods that we have talked about, either in order, post order, or pre-order. And that is exactly what we are going to do right now. The main thing is just specifying which order we want them to be. And let's see. It is really simple. Sometimes it's hard to explain, but in programming it is much simpler. I'm going to do a very simple function. It's not a method, it's a function because it's inside of the main program. It's not inside of a class. So let's call it print tree. And this is going to receive my tree. So right now root is a single node, but it is connected to another node, another node, another node. It became a tree. So I'm going to do this, and I can do, look, I'm going to do print data, then call left, then call right. So I'm going to do print data, call the same function on the left part and on the right part. If I print the data before the left and right, since it's before them, it's pre. Pre means before, so pre-order. If I take the data and put it in the middle, in here, it's going to be in orders between them, in the middle of them. If I print the data after them, it's going to be post order. Post means after. Okay, and what I'm going to do, I'm going to make this as pre-order. So, sorry, in order. So I'm going to do something like this. Okay, let's do it. So I want to call, this is in order. So I'm going to call left, then my data, then right. So I'm going to do print tree, call the same exact function. This is a type of recursion, and I'm going to do tree.left. I'm going to copy this. I'm going to do print tree.data, and I'm going to do a paste of what I copied earlier and do tree.right. This way I'm doing in order printing, and then I'm just going to call my function. So I'm going to do print tree and give it the root. So this root is the same as this root, which is one node. Then we connected it multiple times to multiple nodes, which made it as a tree. When I send this root here, this is the name of the parameter. So the root became named as tree, and we are going to call the left, then print, then the right, and this is in order. Let's actually check it and see that, oh, there is an error. Okay, so I think I got where my problem is. It is keeping on going to the left, which means I am working with recursion that is not stopping. And actually, when I look at the function in here, I realize that I did not put any type of condition to stop the recursion. Okay, to stop it from going to the left and to the right. So that is my mistake. Sorry, that's on me. So we have to do if tree is not none, or we can do just if tree. While it is not none, do the following. Let's check if that's going to work. Of course, we have to use the right space because we put the if statement in here. Okay, fingers crossed, and oh, it is working. Now we are using in order, and let's check that. So in order means left, middle, then right. So that means in here is going to be 3 because there is no left. 3, then right, 99. So 3, 99, 50. Then it's going to be 0, 20, 101. 0, 20, 101. We can see that that is working. If I change this, if I copy this part in here and just put it here, that made it pre-order. Run it. Those are the numbers for it. And if I take this from here, this line, and put it right here, that makes it post order. Again, run it. That is how it's going to look like. I'm going to keep the in order just because I like it for no other reason, and run. And as you can see, that is a really simple program. We did all of this inside of main. This program is just to show you an explanation or a simple example of how a tree can be programmed using Python. In the next lecture, we're going to see a real program. We're going to go directly into creating a real binary tree and trying to get as full of a program as we can. Thank you so much for listening, and I'm going to see you soon on the next lecture.